have audio now? What? Any microphones? Itamar, you want to see if your microphone works?
Hello?
His works. All right, everybody. So we're up and running, so let me introduce Itamar, who's going to talk very quickly about all these topics.
Okay, can everyone hear me? Sounds like it. Okay, hi, my name is Itamar. Thank you all for coming to hear me talk. So today I'm going to talk about how you should test your software. And I'm going to start with some mistakes I made when I was a young and inexperienced programmer. I'll talk about a model that maybe will prove helpful for you testing your own software based on what I've learned over the years. And then I'll talk about some common mistakes people make when they're testing their software. So how should you test your software? When I was a young and inexperienced programmer, I basically just did some ad hoc manual testing. So I'd develop a web application or some sort of GUI, and I'd click around and make sure things seemed to work. And if my clicking around showed no problems, I would ship the software. And over time, I discovered this approach had some problems. I would end up shipping code that was broken. Or even if I'd tested enough manually, the code that I'd written that worked when I tested it eventually would break later on. And so I discovered over time this wasn't the best approach to testing. Later on, partly working on the Twisted project with Glyph, who spoke before me, I learned a different way of testing software. And this method was automated testing with a goal of 100% coverage of all code paths through your software. And in some ways, this was an improvement over my previous method of testing. But over time, I discovered that this approach also had problems. So for example, there are things that automated tests will not catch. And there were cases where I would end up changing my code, and so I'd have to change the tests, and I'd change the code again, and I'd have to change the tests. And some of the time, the automated tests are really helpful, and some of the times, it felt like I was just wasting my time when I was writing these tests. And finally, the goal of 100% coverage has its pluses, but it also has its minuses, and you will often find yourself trying to test something that isn't really amenable to testing. You'll end up writing really brittle and not really that useful tests. And the problem with both of these answers, ad hoc manual testing and 100% automated test coverage, is that they're inflexible. They're a single answer. They don't give you any options. They don't give you any choices. And the real answer to how you should test your software is that it depends. It depends on your situation. It depends on your goals. So if you're writing a video game, you're going to test your software very differently if you're writing a medical device. If you have hundreds of thousands of users, you're going to test your software very differently than if you have no users. And so really, there is no one true answer to how you should test your software. It all depends on the specifics of your situation. And I could leave it at that, and I could just walk off the stage, but while this answer is correct, it's not a useful answer. And so today I'd like to share a model that I think can help you answer the question of how you should test the software in your particular situation. But in the end, this is just a model. It's just a series of suggestions. And the real answer is always, it depends on the specifics of your particular situation, your particular software, your particular goals. And so the model I'm going to be going through has 4 different kinds of testing, and I'm going to go over them as I go through the talk. So I'm not going to focus on them right now. But it's worth noting the 2 dimensions of this model. The top and bottom, the 2 halves, are 2 different kinds of tasks you do when you're writing software. The top half is learning. In order to know what it is you're going to build, what your product is for, what it should do, you need to learn. And there's forms of testing that are oriented towards learning. And then once you've learned what you're going to build, there's a second half, the bottom half of this model, which is actually building something. Now that you learned what you want to build, you have to go and build it. And there's forms of testing that are more oriented towards helping you build your software. And left versus right is 2 different ways you can test your software. You might have automated tests, like unit tests, for example. But you also might have a human being testing your software, doing manual QA or code review, and other forms of testing I'll talk about. And I'll go into each of the boxes, and go over this in more detail as I go through the talk. And to help explain this model, I'm going to give the example of a new company, a startup. Let's say you are starting a new company. You have no product and no users. You're starting from scratch. But what you do have is an idea for a product. You've decided that you have a better way to help people prepare their taxes. It's not very exciting, but you think it can make a really good business. But before you spend the next 6 months or year or 5 years of your life trying to build this product, it might be worth knowing if this is a good idea. And the way you can do that is by testing that idea. And so a common methodology for startups these days, lean startup, which I have to admit is not my favorite methodology, but it has some useful ideas. And one of those is the idea of a minimal viable product. And so the idea is before you go and spend 6 months or a year building a full-fledged product with all the features that you think you need, something that you can actually go and sell, you want to build the smallest possible thing that you can, the minimal viable product. And the goal of a minimal viable product is not to be used by users. You're not writing it for your users. You're writing it for yourself so that you can learn something. And what you're trying to learn is whether or not you're going to actually get any customers, where anyone cares, whether your idea is any good. And so you build the smallest possible product that you can that will actually give you this new information about whether or not anyone cares about your idea, whether there's a new market for tax preparation software. So you start with your idea. You test your idea. And let's say that your minimal viable product, which you showed to people, was hugely successful. Lots of people liked it. Lots of people really want to use the real thing. And so now you've learned something new about your users. First, you learned they existed. Like, you learn that there are actually people who will use your software. And that's a really useful thing to know before you build a new product. But you've also learned something about the requirements for tax preparation, the specific situations that most people have. You now know more about your users than you did when you started. And so what you've been doing at this point is a form of testing. You are testing your business idea. You're testing your product idea. And the goal of this testing is to understand your users. And that's the first box, the top left quadrant. And the goal of this form of testing is to learn something. That's why it's in the top half. And it's a form of testing that can only be done by actually involving real human beings. You need to interact somehow with real users, with real people, in order to understand your users. You can't build a software model that will tell you whether a product will succeed, whether it'll get customers. And so, having come up with an idea and tested it, you've learned about your users. And now it's time to actually build your product based on what you've learned. And so what you're going to do is you're going to create a specification. You're going to create a set of features and requirements of what it is your first iteration of your product is going to do. And then you're going to go off and you're going to implement that specification. And your product specification might be very vague. Like, it might just be a very general statement about what you're trying to achieve, and that can be fine. It might be very, very detailed, depending on what it is you're trying to specify. It might be very high level, so you might say something like, users can file taxes using our software for this particular set of tax circumstances, or users can sign up, or users can pay us for our service. And those are very high-level requirements. And as you flesh out your design, as you start writing code, your design is going to get more and more detailed. And eventually, it's going to get down to the level of, we're going to have a library that helps you calculate taxes as part of internal implementation of our product, and we're going to get down to the level of specification of functions in your code. So this function takes the income and deductions for a particular person and spits out the answer of how much taxes they owe. And so you have a high-level specification, you have a low-level specification, and everything in between. And now you have a new goal for testing. You want to make sure your software is correct. In between what you set out to build, the specification, what you actually build, there are inevitably going to be mistakes, slip-ups, things that go wrong. Maybe the specification was too vague. Maybe someone forgot something. Mistakes happen. Your software is never going to be an exact representation of your specification. There's always going to be gaps. There's always going to be things that are not quite right. So you want to make sure by testing, you want to test your software to ensure that users can actually file their taxes, that taxes are actually being calculated correctly. And if you're going to do this, automated tests are not actually that helpful. Automated tests can't prove that your software is correct. An automated test, a unit test, for example, can say, for these inputs, I get this output. For this income and these deductions, I get this number in owed taxes. But that automated test, that unit test, let's say, does not tell you that you're calculating taxes correctly. All it's saying is that you consistently get the same results for the same inputs. An automated test can't tell you that users can file taxes. It can tell you that if someone clicks on a button, they get shown a particular text on the screen, and so on and so forth, if you have an automated test for a user interface. But that doesn't tell you that an actual human being can file their taxes. All it says is, if you click on this button, some text is displayed. On the other hand, a human being can actually understand your code. A human being can actually understand what the software is for. A human being understands your user interface. Human beings provide meaning. And so you can hire a tax accountant to review your tax calculation. Maybe you look at your code, maybe look at the inputs and outputs of sample calculations. You can do some manual QA where you actually try to use the application and file taxes with it. You can ask a colleague to review the code you wrote to make sure that the code that you wrote is actually the code that you intended to write. And all these things require human testing. This is the second form of testing that you might want to do in your product. It's in the bottom half of the model, so it's about helping you build your software based on your specification, based on what you've learned. But it's still on the left side because it's still testing that involves human beings. If you want to test for correctness, you have to have a human being in the loop. Only a human being can provide meaning. Now, human beings are adaptable. If you change your user interface, if you move the menus around, if you change the text on the button, show the new UI to a human being who's used the old UI, the human being might complain a little, but they'll figure out how the user interface has changed, because human beings understand, and so they can adapt. The flip side of this is that human beings are really bad at details. We will gloss over small changes. Our brain will fill things in. There's probably a spelling mistake somewhere in my presentation that my brain has just hidden from me, and you're all going to see. And on the other hand, computation is brittle. Computation can't adapt. If you change your user interface enough, an automated test for a user interface is going to break. It's going to say, I can't find this field, I can't find this button, I don't know what to do. It's going to throw an exception. The flip side is that computation runs consistently. Every time you run your software, it will do the same thing over and over and over again, the exact same thing. Human beings are slow and they're expensive. Hiring a tax accountant every time you change your code is going to slow down your development and cost a lot of money. While writing software still involves humans, once you've written some software, computation will run quickly and cheaply. It doesn't really cost you much money to run your test over and over again, and they'll run much faster than a human being can test your software. And so when you want to prevent change, you need automated tests. Now, when different parts of your products will stabilize at different points in time. So, for example, your tax calculation is going to change once a year when the new tax code comes out. And so as soon as you know that your tax calculation is correct, you want to write some automated tests. You want to write some unit tests to make sure that your tax calculation doesn't change when you change the code. You want the tax calculation to stay the same. However, if you're redoing your user interface once a week, automated tests don't really help you because the automated tests are there to prevent change. And if you're redoing your user interface once a week because you're still in the prototyping stage, you don't want to prevent change. You are changing it constantly. On the other hand, if your user interface is stable, automated tests can be helpful in making sure your user interface doesn't change when you change your code. It doesn't regress, you don't introduce bugs when you change your code. Now, preventing change has costs because every time you have to write the test, first of all, which is fairly obvious, but also every time you change your code, you have to rewrite your tests. And because different parts of your code stabilize at different times, you'll have parts of your code that aren't stable. And if you write tests for those parts of your code, you're going to have to, every time you change that code, you're going to have to write tests, and those costs are going to add up. So implementation details, private implementation details, always told not to test them. And the reason is you don't want to have the cost of maintaining tests that you're going to have to be changing anyway. You don't want to prevent change in your implementation details. You don't want to prevent change in a prototype. And in many ways, that means 100% automated test coverage isn't a useful goal if different parts of your software have different levels of stability at the same time. It may be that half of your code base needs to be stable and not change, and the other half you're happy to change at any time because other tests are going to make sure the overall system doesn't change. And so this is the third form of testing, testing to prevent change. And again, it's the bottom half. It's helping you to build your software, to build software that doesn't change in ways you don't want it to change, make sure tax calculation stays the same. And it's a form of automated testing. And so far, you've learned from your users by building a MVP, a minimal viable product. You've built the first iteration of your product. And now you want to learn some more about your product by actually putting it in front of users, putting it into production, seeing what happens when people use it. Now, what happens when you run your software in production? It crashes. And so, for example, our AV system failed after I plugged my laptop in. It's probably not related, but I also had an AV failure in my test run at the Boston Python meetup, so maybe it is my laptop. And the issue is that software quickly becomes too complex to comprehend. There's too many moving parts, too many ways in which the real environment, the AV system, is not the same as a test environment, the AV system in the speaker room. Too many ways, too many different inputs. You can't really predict in advance how your software is going to run. You can't know what's really going to happen until you actually run it. And so what you have to do is you have to run your software in a realistic environment and learn from what actually happens. And this is basically a form of testing. You're testing your software to see what happens. So you can do load testing. You can spin up some servers and try to send lots and lots of queries against them in a realistic manner as possible and see what happens. Learn something new. Maybe your software fails over. Maybe your software isn't fast enough. You can also collect the errors and tracebacks from your production logs and look through them and see what's going on in your real system, because there will be errors in there you didn't expect, strange interactions that the only way you could have learned about is by actually observing your system running in a real environment. And this is the fourth form of testing. It's a form of automated testing. It's on the right, because you really don't want a human being doing load testing. You don't want someone hitting refresh on the browser as quickly as possible to do load testing. You don't want a human being manually extracting stuff from your logs. Software is a lot better at that. But your goal here is to learn something new, learn how your software actually behaves when you run it in the real world. And so far, you've learned about your users, you've built your first iteration, you've run in production, and now it's time to learn some more from your users who are actually going to be using the product. You might do usability testing. You might see what problems your users have when they use the user interface, what things confuse them, what problems do they have. You might do A/B testing. If you have enough traffic, you can try 2 different versions of user interface and see which one leads to more good outcomes for your users. And more generally, just by having users use your software, you're learning new things about problems in your software, bugs in your software, features that are missing, things you could do better. And so what you end up with is that software development is a cyclical process. You start by understanding your users in order to learn what it is that you actually need to build for them. And then you set out to build that, and you want to make sure that what you're building is correct, what you intended to build. You want to make sure that parts of it that need to be stable are stable. You want to prevent change in things that aren't supposed to change. Then you want to make sure your software runs successfully in production, so you want to run it and observe the problems it has so you can fix that. It's understanding runtime behavior. And then you circle back to understanding your users by doing things like usability testing when they actually use your product. And in each iteration, in each cycle through this process, you end up with better software, more features, happier users, and hopefully a better business if that's what you are. And so next, I'd like to talk about some common mistakes and pitfalls you might encounter when testing. So one mistake is focusing too much on correctness and not on preventing change, which is what I was doing when I was an inexperienced programmer. Manual testing is great for proving that your software is correct, but doesn't ensure that your software will continue to be correct. The fact that a tax accountant signed off the calculation doesn't help you if a week later you've changed the code and broke it. And so you need automated tests to keep things from changing in ways you don't expect. Another mistake is over-focusing on building and ignoring learning, going off in a cave and just building a product and hoping that it will be a success. You need that feedback cycle going back and forth between building and learning in order to know whether or not what you're building is actually usable, if what you're building actually does what it's supposed to for actual users. So you have to go back and forth and have both sides. You can over-focus on automated tests. Automated tests are great for preventing change, but they don't tell you that your software is correct. The fact that your tax calculation always gives the same results when you run it doesn't mean that those results actually match what the IRS or tax authorities want. And so you need, in addition to your automated tests, you need some human tests who's testing, some manual checks by a human being who understands your software to tell you if it's actually correct. And finally, there's the common mistake of trying to prevent change for something that is always changing. The implementation details, the private details of your software don't need to be stable. They're private. You should be able to change them anytime you want. If you're redoing some piece of your software once a week, you shouldn't be trying to prevent change because you know you're going to be changing it. And so if you know something either will be changing rapidly or you don't want to prevent change. You don't want to write automated tests because those tests impose a cost of maintenance and writing them in the first place. And you can't simply say that preventing change is always a positive. And so this is the model. And it's just a model. And if you're going to build software, in the real world, the way you write software isn't going to quite match it. If you're building a library, you might be your own user, and you're going to have a lot more of a focus on preventing change. In fact, you might write unit tests and then hand them over to someone else to do code review, and then testing for connect functionality happens after testing for preventing change. And so the takeaway isn't that you should follow this model, although I do think it's useful in many cases. The takeaway is that testing depends on your particular situation. And it's unlikely that there is one form of testing that will actually provide all the answers that will solve all of your problems. Different times of your product's life cycle, you're going to need different forms of testing. And different kinds of testing provide different kinds of value and also have different kinds of costs. And so chances are you're going to have to combine different forms of testing from all of these quadrants in order to test your particular product. And that's all. You can find slides and a cheat sheet up at that URL. And if you have any questions about testing, I'm happy to answer them by email or in person. And we might even have time for, nope, we do not have time for Q&A. But I'll be outside. Your tests, and then I change the code again, and I have to change the tests. And some of the time, the automated tests are really helpful, and some of the times, it felt like I was just wasting my time when I was writing these tests. And finally, the goal of 100% coverage has its pluses, but it also has its minuses, and you will often find yourself trying to test something that isn't really amenable to testing. You'll end up writing really brittle and not really that useful tests. And the problem with both of these answers, ad hoc manual testing and 100% automated test coverage, is that they're inflexible. They're a single answer. They don't give you any options. They don't give you any choices. And the real answer to how you should test your software is that it depends. It depends on your situation. It depends on your goals. So if you're writing a video game, you're going to test your software very differently if you're writing a medical device. If you have hundreds of thousands
about all these topics.
Okay, can everyone hear me? Sounds like it. Okay, hi, my name is Itamar. Thank you all for coming to hear me talk. So today I'm going to talk about how you should test your software. And I'm going to start with some mistakes I made when I was a young and inexperienced programmer. I'll talk about a model that maybe will prove helpful for you testing your own software based on what I've learned over the years. And then I'll talk about some common mistakes people make when they're testing their software. So, how should you test your software? When I was a young and inexperienced programmer, I basically just did some ad hoc manual testing. So I'd develop a web application or some sort of GUI, and I'd click around and make sure things seemed to work. And if my clicking around showed no problems, I would ship the software. And over time, I discovered this approach had some problems. I would end up shipping code that was broken. Or even if I tested enough manually, the code that I'd written that worked when I tested it eventually would break later on. And so I discovered over time this wasn't the best approach to testing. Later on, partly working on the Twisted project with Glyph, who spoke before me, I learned a different way of testing software. And this method was automated testing, with a goal of 100% coverage of all code paths through your software. And in some ways, this was an improvement over my previous method of testing. But over time, I discovered that this approach also had problems. So, for example, there are things that automated tests will not catch. And there were cases where I would end up changing my code, and so I'd have to change.
We have audio now? Yes. What? Any microphones? Itamar, you want to see if your microphone works?
Hello?
His works. All right, everybody. So we're up and running, so let me introduce Itamar, who's going to talk very quickly.
Of users, you're going to test your software very differently than if you have no users. And so really, there is no one true answer to how you should test your software. It all depends on the specifics of your situation. And I could leave it at that, and I could just walk off the stage, but while this answer is correct, it's not a useful answer. And so today I'd like to share a model that I think can help you answer the question of how you should test the software in your particular situation. But in the end, this is just a model. It's just a series of suggestions. And the real answer is always, it depends on the specifics of your particular situation, your particular software, your particular goals. And so the model I'm going to be going through has 4 different kinds of testing, and I'm going to go over them as I go through the talk. So I'm not going to focus on them right now. But it's worth noting the 2 dimensions